It says d by dx of this thing. First of all, what is this saying? So the question just says find this. What does this mean? Yeah, exactly. So this is my function, and this brackets, this literally just means it's an operator. Differentiate this. This is what d by dx means. It means differentiate. Okay. So can I differentiate it in its current form?
No.
Why not?
Because we're going to have to multiply it.
Yeah, good. So it's not a linear combination of terms that look like this. Okay. Because at the moment it's like fractions, and it's got square roots and all sorts of fun stuff in there, right? Okay. So I need to rewrite this first of all. So let's try this. So d by dx of, so this just means differentiate this. How could I rewrite this?
Do we put the x up?
So first of all, I'm looking at that square root of x. How could I rewrite that? Yeah, good. So I could have x squared plus x to the power of 1 over 2. Sorry, I didn't hear you. Minus 6 all divided by x. Good. Okay. Now, are you happy here? Are you happy here? I've got a sum of terms on the numerator, and it's every single term is being divided by x. That's literally what this means. So x squared gets divided by x. X to the power of a half gets divided by x, and negative 6 gets divided by x. So I could literally write it like that. I could say this is d by dx of x squared divided by x plus x to the power of a half divided by x minus 6 divided by x. Okay? And then it's just indices. So what's x squared divided by x? Good. X squared divided by x is x. What's x to the power of half divided by x? Good. I just subtract those powers, yeah? Half take away 1. And then how could I rewrite this? Negative 6 divided by x. Good. Are you happy now? It's in a form that I can differentiate. Okay. So really, the hardest thing about this step, these indices, the hardest thing about this differentiation is rewriting it in a form that you can definitely differentiate it in. Is that okay with everyone? Yeah. Good. Okay. So in which case, let's have a go at this. What's that thing differentiated? What's x differentiated? It's just 1. What's this thing differentiated? Good. What's this thing differentiated? Perfect. Well done. Yep. Okay, and then I just leave it in the form that I got given it in, so with roots and fractions and things. Yeah. So you have 1 minus 1 over 2 root x to the power of 3 plus 6 over x squared. Is that okay? Quick question. What would this thing differentiated be?
3.
Why?
We can't put a number at be 0. Oh wait, do we put plus c?
Well, at the moment, I would argue this is not in a form that I can differentiate in, because it's not something x to the power of something. Not every single term is written like that. So let's just explicitly write it. So I'd have d by dx of, well, this, I know I haven't got it here, but what is the power of the x?
1.
Good, so I'm going to write it like that just for the sake of clarity. What is this power of x? There must be a power of x there, otherwise I'm not able to differentiate it.
0.
Good, so it's 4x to the power of 0, because of course x to the power of 0 is just 1. You okay with that? Yeah. And then if I differentiate each thing, then this is going to become, well, the 3x to the power of 1 is going to become 3 times 1, x to the power of 0. And this is going to become, well, 0 times 4, 0 times 4, 0 times 4, x to the power of negative 1. Okay, and then if I tie that up, 3 times x to the power of 0 is just 3, and then 0 times anything is just 0. Yeah? Does that surprise? Were we expecting that? So think about what we started with, 3x plus 4. Were we expecting that the gradient function came out to be 3?
I was.
Why?
Because I learned that when there is a number without a coefficient, it's always going to be 0.
Good, but can you see why that's the case now? So why does 4 just become 0?
Because it has a coefficient of x with the power of 0.
Exactly. Or if you think about this, if I was going to plot the line y equals 4, what would that look like?
Y equals 4. A straight horizontal line.
Good. Going through 4. So what's the gradient here? So remember, gradient is every time I move across by 1, it's how many I move up or down by. If I move across by 1, how many do I move up or down by? 0. So therefore, the gradient of this line should be 0. But also, have a look at what we started with, 3x plus 4, 3x plus 4, okay? What type of line is that? It's a straight line. It's a linear graph, right?
Yeah.
And you know, because it's in the form y equals mx plus c, what would the gradient be? The m, the 3, yeah? So what I'm trying to show you there is that actually differentiation is just a more general case of exactly what we've already dealt with. We've already dealt with straight lines. We've already dealt with coordinate geometry. We're okay if I give you this, you tell me, oh, I know this. The gradient is 3. It's exactly the same thing, but now differentiation is a more general way because it also works with horrible functions like this.